Problem number 5 says, consider the differential equation, draw a slope field. Okay, so when I think about these slope fields, I start with what will turn the top into 0, or what will make y equal this thing equal to 0. If I plug in a 1 here, anywhere y is equal to 1, I'm going to have a 0 slope. So I've got a 0 slope here, and a 0 slope here, and a 0 slope here. Now, when I come to the bottom, when the bottom is equal to 0, I have undefined slopes. And I have undefined slopes at x equals 0. Now, this point here is a very interesting one, and I find it very disturbing. And I'm disturbed by it because it's at this point here, at the point 0, 1, we've got 0 over 0. And that's our indeterminate form. And I might think, well, should I be using L'Hopital's rule? And the answer is, I don't think so. When I look, let's look at their solution. There's no slopes drawn here because they're all vertical. Well, yeah.
Mr. Kukla?
Yes, please.
I thought there were no slopes drawn because it says x cannot equal 0.
X, oh, where x is not equal to 0. Oh, thank you, Brian. I appreciate your eyesight. So that helps us avoid this terrible, terrible situation. Okay, so 1, they want the 0 slopes. Those were the ones that I filled in first. And another point for these other 6 slopes. Okay, any questions about finding these 6 slopes? Okay. Next, find the particular solution. So here we're supposed to do our separation of variables. And we integrate both sides. On the left, I get ln of absolute y minus 1. On the right, be careful, this is x to the minus 2. This isn't ln of x squared. This is negative 1 times x to the minus 1, negative 1 times x to the minus 1. Or if I bring, because when I take the derivative and I bring down that negative, I'm going to subtract 1 here to get that negative, and negative times negative gives me that positive. So this has to be my antiderivative. I exponentiate both sides. I got rid of the absolute value and brought in that plus minus. I also did that little algebra thing where I pulled the e to the c into its own. I called plus and minus e to the c equal to b. And so now I have y equals 1 plus b e to the minus 1 over x. I use the initial condition. They really like to see evidence of you using it, not just you doing it in your head, because we don't know if you've done it in your head, and solving for b. So I get that b is e to the 1/2 power, and I plug that value back in, and I ended up with this. But because these bases are the same and I'm multiplying, I just wrote e to the, and I added these together, and that's what this is. On this problem, it's 6 points. Oh my God, 6 points. I'm getting 6 points for this, 1 for separation of variables, 1 for each of the antiderivatives being correct. And I will tell you that what happens with the reading is, let's say you got this antiderivative correct, but not this one correct. As long as you got one of them correct, the reader would keep reading to see if you used the initial condition properly. So, includes the constant of integration. Do you have the plus c showing up at the right time? And then using the initial condition. So even if you lose one of these points, you're still open to getting these 2 points. You could still get 4 points. You can't get the answer because your second integral was wrong. But you could get 4 out of 6, and that's still really good. 6 out of 6 would be really nice. Notice here, a maximum of 3 out of 6 if no C showing up. And this one, really scary, 0 out of 6 if no separation of variables. Even if you come up with the correct answer, No points out of 6. So watch out for that. Okay.
Mr.
Yes,
Kukla,
please.
can you go back and explain to where you plugged in the initial condition?
This one here. So
Yeah.
I plugged in a 2 for the x here, and I plugged in a 0 for the y. Okay, and so I have negative 1 over 2, and I have my b, e times that, plus 1 equals, so I subtracted 1. And then I said that e to the minus 1/2 was the same as 1 over e to the 1/2. And the reason I wanted to think about that was because I was troubled about how to get b by itself here. And I thought, well, I guess I could divide by that e to the negative 1/2 on both sides. But then I remembered, Mr. Cleese talking all the time about when you have a negative exponent, why don't you flip it and make it positive as the first thing you do? So I flipped that negative exponent down to make it positive. And then to get b by itself, instead of dividing, I'm going to multiply both sides by e to the 1/2. I end up with exactly the same answer. There's my b value. And so I'm just tucking that in for b. And then I said, well, and you could stop here, but I noticed here on the scoring guidelines, they didn't stop there. They are fond of their algebra. And because these have the same base, and I'm multiplying them together, I add those exponents, 1/2 plus negative 1/2 x. I'm sorry, 1/2 plus negative 1 over x. And so that's what I've got here, just that one base instead of both of them joined with multiplication. Hannah, any questions about that?
No, that makes sense. Thank you.
Okay. Anybody else? So we've taken care of 8 of the 9 points. The last point comes from, for this particular solution, what's the limit as this function heads to infinity? Well, if I plug an infinity in here, I have 1 over infinity, 1 pizza, an infinite number of people. That's going to be big old 0 pizza for you. And so this goes away. And all I'm left with is 1 minus e to the 1/2. And so that's the value of the limit. The limit of f as x heads to infinity is 1 minus e to the 1/2. And I get 1 point for that answer. Any questions about these 9 points? Again, if you're in the place where, you're getting 5 points on this problem, great. That's fabulous. If you're getting more than 5 points, you're well on your way to a 5. Nationally, the numbers are not 5 for this problem. They're lower. And so when we're above, we're happy campers. Okay, last question. Function given by f of x equals ln of x over x for x values bigger than 0. I caught it that time, Brian. Thank you. The derivative of f is given. Well, that was nice of them to give me a tidy derivative. And so I don't have to use quotient rule. Write the equation of the tangent line to the graph of f at e squared. So I need 2 things, Riley would tell me, to write the tangent line equation. I need the ordered pair and the slope at that point. So I plugged in e squared into f, and that gave me this. I used the power rule to bring the 2 down in front. And ln of e was 1. So I've got 2 over e squared as the y value. So I guess I have an ordered pair here called e squared comma 2 over e squared.
Mr. Kukla?
Yes, please.
What if you didn't simplify all the ln stuff and just left it as when you plugged in the e squared? Do you think they would not allow that?
As long as it was correct, it would not be wrong.
Okay.
They might want to gnash their teeth and rend their cloth in anguish, but no, it's a calculus test. Sometimes, though, students get themselves in a position where they need the tidier answer later. I don't know if this is one of those situations, but that would be the only concern. And especially since we're not worried about multiple choice, you know, that's where really that kind of thing shows up, where they're always doing those shenanigans about simplifying, especially log expressions. Okay, so I plugged in the e squared over here into f prime. I did that same thing with the power rule, bringing down the 2, which gave me 1 minus 2 on top, or negative 1. And e squared goes in here and gets squared. So that's going to be e to the 4th. Watch out for that. That's an easy place to lose a point. We've got x being squared. Our x value is squared, so we're squaring a squared thing. That's why this is e to the 4th. So there's my slope at that point, and therefore here's my tangent line. Y minus the y value equals the slope times parentheses x minus the x value, close parentheses. What am I getting for that? I'm getting 2 points. I get 1 point for both of these being correct, and I get 1 point for a correct tangent line equation. And correct, like Hannah said, it doesn't have to be simplified to be correct. Yeah. Okay, part B. Find the x coordinate of the critical point. Look at that. They tell me there's only one critical point. That's kind of cool. And I know a critical point occurs when the derivative is equal to 0. So I set f prime equals 0, which they gave me f prime, which means the numerator has to be equal to 0. So 1 minus ln of x equals 0, which means 1 equals ln of x. We exponentiate and get x equals e. So E is the critical point. What am I supposed to do with it? I found it. Determine whether this point is a relative min, max, or neither, and justify your answer. So I said, oh, well, this is a great opportunity for me to use the second derivative test, because I know the derivative is equal to 0. And so then I look at the second derivative, which meant I had to use quotient rule on this. I used the second derivative and I plugged in that critical point of e, and I determined that the second derivative evaluated at e was going to be less than 0. Now, how did I know that? Well, the bottom is always positive. And here, Hannah, this is definitely a situation where I want to be able to simplify this, or I'm not going to be able to say whether this number is positive or negative. Here, I've got negative 3e plus ln of e times 2e. Well, that's 1 times that. And when I add these together, I just have a negative e on the top and e to the 4th on the bottom, or negative 1 over e to the 3rd, which is definitely less than 0. And so because the second derivative is less than 0, I know the original function would be concave down and have that horizontal tangent at the point x equals e. And so I'm looking at a max at x equals e, according to my second derivative test.
Mr. Kukla,
Yes, please.
is that doing the second derivative? Is that easier than just like finding the critical point and then like plugging in values left and right of it on like for the first derivative?
So let's think about that. You've got this first derivative, f prime equals 1 minus ln of x over x squared. And we came up with a critical point e. And you want to plug in something over here. So what are you going to plug in over there?
I don't know.
Okay. You know, the number 1 is less than e, because that's 2.7. So if we plug in a 1, ln of 1 is 0. I get 1 minus 0 is 1 on top, 1 on the bottom. I get 1. 1 is positive. And if I plug in something over here, I like e squared, because if I have the ln of e squared, I can bring that down and get 2 times 1, or 2. 1 minus 2 is negative 1 over e to the 4th, and that's definitely negative. So I've got a max there. Why did I need to do the second derivative test? And I think the answer is I didn't. I didn't. Um, okay, so let's take a look at the scoring. Why, look, because f prime changes from positive to negative there, just like Hannah suggested. So 1 point for identifying x equals e, 1 point for claiming that we have a max, and 1 point for a correct justification, whether you're appealing to f prime or silly appealing to f double prime. Okay, yeah, it never crossed my mind, Hannah, to check f prime there, but it makes so much sense. Good job, you. Okay, and then we've got part C. The graph of the function f has exactly one inflection point. Oh, maybe that's why I did it. I did it because I knew I was going to be using the second derivative here. So if I had to find the second derivative anyway, I sort of, got double duty out of it. So here was my second derivative in its untidiest form. If I set the top equal to 0, that will help me find a critical point. I added 3x to both sides. I divided by 2x. That gave me 3/2. ln of x equals 3/2. I exponentiated and got x equals e to the 3/2. So I made an f double prime sign chart and I checked e to the 3/2 and I looked at either side. This is e to the 1.5 power. So I used e to the 1 and e to the 2 on either side. And I did see a sign change there. And because there's a sign change in f double prime, that means that we at x equals e to the 3/2. That means there's an inflection point on f at x equals e to the 3/2.
Mr. Kukla?
Please.
So we divided 3x by 2x. In
Yeah.
future problems, will we lose solutions by doing that?
Well, can x equal 0?
No.
No, not with this old
So, yeah, not in this problem.
Not
But
in this problem.
like-
I
happen in
am
other problems.
always reluctant to divide by a function and throw things away, but I will say on the AP exam, it's written for people who aren't as smart as almost all the people in our calculus class. I know that because our percent of people getting 3, 4, or 5 is 97%, while nationally it's only 59%. This test is written for a lot of really stupid people, and they don't put stupid people in the position of having to even think about throwing solutions away. Often what happens with our students is we get tripped up because we're looking for maxes at endpoints, but in the directions they slyly slid in, oh, don't include the endpoints, because most American students aren't even going to remember to look at the endpoints. So Brian's claim of pay attention to what the question is actually talking about, look at those boundaries that they give me, I think that's going to be more useful than worrying about the extraneous solutions. I'm really glad you thought about it, Ethan. I think that's great because I did just sort of cavalierly divide by x on both sides, and that would have been, that would have been where the function was undefined, and we could have grabbed that by setting the denominator equal to 0.
Okay.
But I knew that the original function itself wasn't defined there. So
Right.
I knew I didn't have to worry about that. And of course, Brian told me at the beginning, hey, for x is bigger than 0. So I got lots of reasons here where here I don't have to worry. But even going forward, Ethan, I don't think you have to worry about it on this exam. As a math major, that's a good thing to be thoughtful of. Okay.
Okay.
And what were we getting for points on that? We were getting 2 points for f double prime. Finding your way correctly through low d high minus high d low over low squared, not simplifying it, just getting to this point got you 2 points. And then a correct answer. So we have 1 point of inflection, and it doesn't say with reason here. We don't have to justify this. So they just want to know that location, okay? And then finally, part D says, what's the limit as x approaches 0 of f? So with this one, I said, okay, if I plug in 0 here and 0 here, I get negative infinity over 0. Well, that's not L'Hopital's. So I said, all right, well, I don't understand what to do with negative infinity over 0. So I'm going to flip this. And kind of like that situation, remember when we have 0 times infinity, what we're supposed to do is take one of these and flip it into the denominator. Well, I'm imagining that I already have that in the denominator, and I'm going to take it and flip it up top. So this x over 1 becomes 1 over x up top here. And now when I put in my 0 and I put in my 0, I get infinity times negative infinity, which gives me negative infinity. No L'Hopital's here. That's a rabbit hole. Any questions about this problem? And I get 1 point for that, was it? Yes, 1 point for coming up with negative infinity or does not exist, depending on your textbook. Okay. Any questions about these 4 problems? Fabulous. Any questions about what you should be doing in the next week? Silence. Nice. Delaney, you asked me a couple of days ago what packet we should be on, and I noticed that on the 6th, I'm supposed to be collecting 4. So you're well ahead then. I noticed at the end of the week, I'm supposed to be collecting 7. And this has us ending on the 5th, but the test isn't until a week later. So we still have plenty of time. I wouldn't stress about that. And because of that, I think you do have time for the multiple choice packets. I think there may be some value in that practice, just like I think there's some value in doing the, integration and differentiation packet and checking my answers to those problems. I think there's value there as well on this test. And since most of you will go forward and take Calc 2, because so many majors require a year of Calc, that makes sense to me that you would want to be comfortable with those basics. We do have a meeting tomorrow, 12:30, I believe it is, to discuss AP quizzes 3, 4, and 5. I still need to post those, don't I? I'm going to take the absolute silence as yes, yes.
What do you mean by post?
Post, like you have access to them.
Yeah, you put them in the group me.
I did put them in the group me? Okay.
Yeah.
And I think that's a nice thing to do and practice. But unlike today's session where I really expected to see everyone, I don't need to see everyone tomorrow at 12:30. If you want to come and you want to go over those 3 quizzes, that's great. But these sessions going over time-free response problems are going to be more important for us. And I decided to throw all the quizzes into that one session just so that we could get done with it and they wouldn't be hanging over us anymore. I think there is some value in those problems. They tend to be thinkier. They're not the Part A problem on AP free response questions. They're more like the Part C question. So I would say they're still worth doing, but I wouldn't stress about doing them. So I'll see some of you at 12:30 tomorrow. I haven't had any requests for a Zoom session for this week, but I'd love to schedule some recurring ones that people could depend on. But maybe you don't need them. I don't know. I don't want to be too rigid. I feel like just this one Monday morning a session a week is going to be enough for some people, but it won't be enough for others. And it's the other people that are often quiet that I'm concerned about here. I would love it if all of you strove for that 5 on the AP exam, because I don't think it's an impossible goal when I scroll through our list of participants. Okay. I think I'm done nattering on then. I'll see some of you tomorrow at 12:30. I'll see some of you probably at a Zoom session later this week. And I'll see hopefully all of you next Monday at 9 with timed AP free response number 2. I will give you a heads up though. The second one is a little longer. I put 6 problems on it. So you might think about doing it in 2 45-minute sessions, okay? And again, it's without calculator. I've noticed with calculator, a lot of the problems that I've seen so far with calculator have been either area and volume or velocity and acceleration, or both. And so I promise we'll get some calculator practice when I find them. But I'm trying to sort of go chronologically, because I think if we experience these problems historically, by the time we get up to the ones from last year, we'll be in a frame of mind that's more in line with what the test is likely to look like this year. Okay? Well, I hope you all have a wonderful rest of your day. I hope you're all doing okay. Please let me know if there's anything I can do. And I look forward to seeing you at our next meeting. Yeah, like that there. All right. Take care, everyone.
Bye.
Thank you.